Okay, so we're looking at problems that involve two triangles. We've learned all that we need to learn in trig for this course. We're putting it together to solve some different problems. So yesterday, sometimes they were, a diagram wasn't given, so you had to read the question, draw the diagram yourself, and use your trig ratios. Today, a lot of these will have two right triangles, and so in order to find the answer that the measurement that you're asked for, you might have to do two calculations. I've written the trig ratios on the side there. Okay, they're in your notes. They are on the formula sheet that I gave you. I gave you a copy. Yesterday on the check-in, I noticed some of you don't remember what they were and you didn't look them up. Okay, if you're not sure, then don't just guess. Look it up on your formula sheet. Okay, I suggest that you try to memorize them. Because no matter if you take 20-2, 20-1, or 20-3, you're doing trig. Trig is in all of them. Okay, so you have to know trig. So take a look at the first one. It says, for the following figure, determine the length of AB to the nearest tenth. So take a look. AB is this entire distance. In Math 20, you will learn how to maybe do it in one step with one formula, but we're not learning that right now. We don't have enough information even for that one. You'll take a look and see that we've helped you out. We've cut it into two 90-degree triangles. So if we want to find that entire distance, I'm going to call this X and this Y. I'm just going to label it. So it's the sort of the horizontal part, the bottom part, the base of each of those 90-degree triangles. Take a look at this left triangle here. I have an angle in a 90-degree. I have the opposite side, okay, is 50. And I want the adjacent side. Okay, well, opposite over adjacent is tan. So take a look at your formulas. So I'm going to set up my equation. Tan of 30 is opposite over adjacent. If I'm looking for the adjacent, and it's in the denominator in this case, right? Remember, if it's in the denominator, you divide. So I've got to take x equals, I've got to take 50 and divide by tan of 30. Okay? So, again, check your calculator, make sure it's in degree mode. Quickly. So, 50 divided by tan of 30. Okay, 86. Now, this is not our final answer. So we are going to keep, if it asks for the nearest, what does it ask for? Nearest, tenth? Then keep at least 3 decimal places. Okay? Why 3? Because we have to do another calculation and add it in this case. So if you round too early, it will end up being incorrect. So 86.603. So I always go 2 more than what it asks for until the end. Saying that, if you have a graphing calculator, it's keeping all of your calculations. So really, we're going to go back and use the unrounded version. But let's say you clear it by mistake. You don't want to have to do the whole thing again. Next part in this triangle, let's do it in red here. So we want to find y. That's adjacent to 40. And now we already have opposite as well. So in this case, it's tan as well. So tan of 40 is 50 over y. So y is 50 over tan of 40. Now what you could do is leave it as exact and then add both of them at the same time in your calculator, but we're doing it in separate steps. So here I'll use the TI again so I can show you how we can do that. And so now that's 50 divided by tan of 40, 59.588, 59.588. And so AB, well, I'll change color maybe. So AB will be those two values added together.
So if you're doing it through your graphing calculator, like when you have both answers, how do you make like add those?
Yep, I'm going to do that. Just a sec. Okay, so here in, this is a TI, same in a Casio. I have the second value. If I go plus and cursor up, arrow up to the previous value, 86.60 whatever, enter on that, enter again, then you don't have to have done any rounding. Miles, can you be quiet, please? Okay, so now 146.2. So equals 146.2, and units are centimeters. Some of you are forgetting units as well. Okay, these are all measurements. So degrees for the angles, whatever unit of measure for the sides. Okay. All right, so next it says determine the area of triangle ABC to the nearest whole number. So triangle, area of a triangle is 1/2 base times height, or base times height divided by 2. We expect you to remember that. So now our base is 146.2, saying that we rounded that. So we hopefully have kept it in our calculator. Okay, if not, you don't want to use the rounded value. So I'll show you in a sec. The height of that is 50. Okay, so this is rounded, but we want to use the unrounded. Sometimes it's not going to matter. It depends on the number. So if I've got that in my calculator, that's great. I can multiply by 50 and then divide by 2. I could go 1/2 times that value times by 50. All means the same thing. So now this is going to be 3,654.8. 3,000. Let's see, I forget already. 654. Oh, and it says nearest whole number. So 3,655. So probably it would have ended up being the same. Let's see, if I had used just 146, so if I went 1 divided by 2 times 146.2 times 50, it would end up being the same to the nearest whole number. Obviously, not to the nearest 10, if we kept it to the nearest 10. What's wrong? What's up? Okay. So here, 146.190. So really use 146.190 to be safe. Okay, you're going to get marks off if it's not rounded correctly at the end for each question, not just for once. Okay. Anyway, close enough. Okay, so angle SPR. Remember, if 3 letters are used, the middle letter is where the angle is. And so you have to follow those because there's more than one choice. So S is here, P is here, R is here. So that means we're looking for this angle. Okay, that's why we're using 3 letters, because if I said angle P, then maybe it's this one over here. So you follow through, SPR. Okay, so what do we know? We only know one side there. In order to calculate an angle, we need to know that it's a 90-degree and another angle. We don't have that. That's the easiest one. Or we need to know 2 sides. So we don't. But notice how this is what we call a common side. It's a shared side with the other triangle. So let's calculate what that is, and then we can use trig to find that angle. So in this triangle here, we have the hypotenuse, and we have the opposite. Okay, so opposite over hypotenuse is sine. So sine of 28 degrees equals x over 18. Okay, if you were to show me this, okay, that has no meaning to me. It just says sin equals x over 18. It's just 3 letters. I don't know what it means because it's always sine of an angle. So we need that angle in there. So it's going to be 18 sine of 28. So I'll use a Casio for this one. All right, so 18 sine of 28. You don't have to have brackets around the 28 if it's just a single number. And that's 8.450. So remember, I'm keeping a few decimal places. Okay, then in this triangle, I now have this side, which is the hypotenuse now, and this is adjacent. Okay. So turn your page around if you need to in order to see, but remember the hypotenuse is opposite the 90 degrees. And so that side we just calculated was the opposite in the left triangle. Now it's the hypotenuse in this triangle. So adjacent and hypotenuse is cosine. So cosine, I'm going to call it theta. Remember, that's a common variable. It's a Greek symbol called theta. It's just a symbol. It's like a variable. But it's often used for angles. Okay? In the Greek alphabet, it's T. It's theta. It starts with a T. But it doesn't look like a T, but it is. Okay? And so then that is adjacent over hypotenuse. So remember, if we're looking for an angle, we're pressing that shift key or second key, depending on which calculator you have. So it's really cos inverse of 6 over 8.450. Now, the thing is, in your calculator, you've got that saved. So when I do this, I go shift key, cos key, bracket, and then what did I say? 6? Is it 6? Yeah. So then bracket 6 divided by, cursor up to your previous answer, enter on that, or execute, I guess it's called here. It will do it for me. Come on. Okay, why isn't it? Okay, so on this, I'm going to do it. So you can, if it's, mine just doesn't seem to be registering when I press that. So what I can do is go shift and then negative, which is the previous answer. You can also do that on a TI, and then it will calculate it. Now we're going to round to 1 decimal place. So 44.8. it's adjacent to theta. It's touching it. I'll erase this so you can see. We want to find this angle in here, and so it is touching it. Oh, angle SPR. Well, do you see the word depression?
No, but isn't the person making the
Well, yeah, read it.
Oh, it does say the word
Yeah.
depression.
Yeah, it's sad. Well, it's also sad too. Yeah. Okay, so from the top of an 80-meter tower, so we're giving you the diagram. This is a common type of question that you will see on assessments. Hint, hint. Okay, so 80-meter tower. Sam spots two fires, one behind the other. If the angles of depression of the two fires are 14 degrees and 18 degrees, determine the distance between them. Okay, so distance between the fires, that's your X, okay? From there to there, okay? The height is 80, so this height here is 80. And always we're assuming that that tower is at 90 degrees, it's not tipped over, right? So it's a 90-degree angle there. So you've got two 90-degree triangles. Now, we don't have enough information. We are told the angle of depression of the two fires is 14 and 18. So there's two of them. Think about that horizontal line going out. It's not very horizontal, but it's close, okay? And so this angle here to the first dotted line is for the far fire, the one coming out the furthest. So is that angle that I just drew there from the horizontal down, is that going to be 14 or 18? 14. Smallest. Okay. The other one, this one here, would be the bigger, 18. Okay, because he has to look more down. Exactly. Now, those aren't in the triangles. That doesn't help us a lot. But remember that whatever this angle is here, this 14 degrees, is going to be this angle here, 14 degrees. Okay, whatever this angle is here is going to be this angle. So this is 18 degrees because it forms, I call it a Z, right? It looks like a Z. Okay, so 18 and 18. It's really because those are parallel lines. So 18 and 18, 14 and 14. Now we have our triangles. Okay. Still, we can't just calculate X right away. Right? X is part of this, what we call an obtuse triangle, that skinny triangle in there. We don't have a formula for that. In Math 20, yep, you'll learn something that maybe you can use to help you. But right now, we have to use right triangles. So the deal is we've got a right triangle, this one here, okay, is inside for the closest fire, and then the outside one. So if we calculate what this is, let's call it Y. Okay, and then if we calculate this distance, let's call it Z, then all we have to do is subtract them. Okay, so last one over up here, we had to add those. Now they're on the same side, so we have to subtract them. So doesn't matter which one you start with, I'll start with Z. So in that outside triangle, this is always, for both triangles, this is the opposite. And these are the adjacent. We don't care about that hypotenuse. It's in the air, right? It's not even measured. So opposite and adjacent is tan. So tan of 14 degrees equals 80 over Z. So Z equals 80 divided by tan of 14. Then for the other triangle, we can calculate that in a sec. I'm going to do the other work and then just get my calculator out. So tan of 18 degrees is 80 over y. So y equals 80 over tan of 18. And then x will be the subtraction of those two values, right? Okay, so we'll do it in the TI this time. So 80 divided by tan of 14, 320.862. Then 80 divided by tan of 18, 246.215, 246.215. Okay, again, if you haven't cleared your calculator, it's pretty fast. So in your calculator, go up if you can. Older versions you won't be able to, but you could still copy out lots of decimal places. You've already copied 3 out onto your paper, so you're still good if you just do that. But newer versions of the calculators, you can copy that out and then subtract the next thing, enter, and then without having to enter too much information. So 74.6, now it's said to round to the nearest whole meter, which would be 75. Okay. If you wanted to, take a look. You could go 80 divided by tan of 14 minus 80 divided by tan of 18, and it would give you that final answer right away. Okay. But if you're worried about, if you want to get part marks, you're worried about in between, it probably is best to show each one. Certainly I will need to see each ratio, right? Some work for it. Some of you just gave me the answer on that check-in. And if it says determine, determine means show work. Okay, another common type of question is sort of, that's a horizontal type question, and this is a vertical type question, but still involves two triangles. So it says Sam lives on the 15th floor of a tall apartment building. One day Sam looks out of his window at a nearby office tower. He notices that the angle of elevation of the top of this tower is 54. So here's Sam here. This is Sam with funny hair. Okay, and so he's looking out from the horizontal up to the top. So I'm actually going to draw that horizontal across, because remember that's going to meet at 90 degrees, and the angle of elevation is 54 here. Okay. Angle of depression is horizontal downwards, and that is 30. Okay. So in that triangle, that's also a 90-degree triangle, because 180 divided when one angle is 90, the other angle has to be 90. And so we're asked to find the height of the office building. We have to know, it is given that they're 60 meters apart here. Well, if they're 60 meters apart at the base, then they're going to be 60 meters apart anywhere, unless the buildings are not built correctly and they're diagonal. So we assume that they are. So that's 60. And so to get the height, we need to find this entire distance. It's in two triangles. So this is very similar to the first question you did, in that we have to find this distance, we'll call it X, and this I'll call Y. So just label it. For these ones, I'm not going to ask for a let statement like you did in the systems, as long as you've labeled it on your diagram. So I know which measurement is X and which is Y, or M, or whatever variable you're using. Just the one thing I noticed on the check-in, some of you for an angle, no, for a side, you were using O for opposite, but O looks like 0. Okay, so try not to use O, because then that's 0. So try to label it with an X or Y or an M or something like that. Or even like if it's labeled, say this triangle is A, B, C, then you could call, oops, sorry, just a sec. Then you could, this side here, remember, if this is capital C, this is lowercase c. This is lowercase a, this is lowercase b, or you could do line segment AB, so the two letters together means that side there, okay, or BC means this, so you can use those methods as well. In any case, I'm going to label them X and Y, and so now in my triangle, I have this angle, this is opposite, and the 60 is adjacent. In a lot of these application questions, tan is often the ratio you use. So if you're stuck, I always say, if you're stuck, use tan. Might not be tan, but a lot of them tend to be tan, more so in the application questions. In any triangle, not necessarily at all, but because often we're not measuring the hypotenuse. So that'll be tan of 54 equals X over 60. So X equals 60 tan of 54. That's the top triangle. And then in the bottom triangle, this is opposite and the 60 is adjacent. So then tan of 30 is Y over 60. So Y equals 60 tan of 30. Okay, get out your calculator. Again, keep a few decimal places and then add them together. I'll do this one in the Casio. So 60 tan 54, and then I'm going to go 60 tan 30. Oh, so if your calculator, if you have a Casio and it is not in test mode, it may give you the exact value. So we need the decimal form. So you go arrow to D, okay, and it'll give you the decimal form. So this one was 82.583. This one is 34.641. So the height will equal the sum of those. Okay, so I can add, I'll just go add. So it takes that previous answer. Let's see if it'll work now for me. If I do that and execute. For some reason it's not. Yeah, it should though. I think it's maybe copy. I gotta have a physical one to look at. So if you can't, I know there's yeah. What did you press? Execute. It worked. Yeah, I think it's something to do with my on-screen version. Okay, so I'm just going to do answer plus. I'm going to copy a lot of the values out. I think it's just it registers something when I'm using my stylus, doubles up sometimes, and then doesn't even do others. Okay, so 117.2. Oh, nearest meter is 117. Okay, so one more question. And this one's kind of interesting. You have to think in 3 dimensions in this one. Okay, if you look at that. So your triangles are not on a flat 2-dimensional piece of paper. So one is on the river, okay, crossing the river, and the other one is vertical. So it says a pump house is on a cliff above a river that is W meters wide. So you can see the little W, that's the width of the river. Chuck, who works at the pump house, maps out a right triangle across the river with dimensions as indicated in the diagram. Chuck would like to install a pulley system where he can transfer supplies from point S here up to the pump house with a rope. Determine the length of the rope from point S to the pump house. So now we are looking for a hypotenuse, right? That is a diagonal. So you've got to kind of look at this triangle here. It's coming out, right? But there's your right triangle. So it's coming out of the cliff, okay? With a 60-degree angle. Determine the length of the rope if the angle of elevation is 60. So they've already labeled the angle of elevation for you. What other information is they've given you this 20 meters and this 24 meters here. So some point down the river, they just measured that as 20 and then across to S. Okay, so we're going to use that to find W. And that's a right triangle looking down from above. So really, if I were to draw that triangle, it would be looking like, oops. This would be W here. This would be S at that point. This would be 24, and this would be 20. So to get W, okay, can I even use trig? No. What do I use? Pythagorean theorem. Exactly. So to get W, it's going to be W squared equals the hypotenuse squared minus the other leg squared. Okay, so I'm going to show it exact. Can I even, I could simplify that. Let's practice. So simplify root 176 because you're going to have to do this on the final exam. Is it more root 11? Is it 16 times 11? It's 176. So it is, yep, so it is 4 root 11. Okay, now Do you have to show it like that? No, not for this question. But in the final exam where we put things together, maybe there'll be two parts to it, right? But in this case, we can just leave it like that, or we can find the decimal form. So root of 176 is 13, again, don't round, so 13.266, at least 3 decimal places. Okay, so we've got W. I'm actually going to use the exact form in my calculations, but now for that triangle, let me draw that one. So now this is 60. We found W here, and the exact value is root 176. And we want to find out the length of the rope. I'm going to call it X. Okay, so that is the hypotenuse, and we have the adjacent. So cos of 60 degrees equals, as I said, I'm going to use the exact value. Then I don't have to worry about rounding. The adjacent over the hypotenuse. And so, really, I didn't have to use, well, I guess you may have used your calculator for 24 squared. In any case, you haven't had to use it too much. And then, so I'll use my Casio this time. So I'm going to go root of 176, cursor out of the root sign, divide by cos of 60. Now, it gives it, again, because it's not in test mode, exact value. And I am going to convert it to a decimal, which is 26.5. And that's meters. Oh, does it say 100? Oh, it does. Sorry. I always forget. So, wrong calculator. 26.53. Okay. Yes, you get the same formula sheet. You have a copy of it right now. Okay.
Why did you do that example? Square root of 176 is equal to 4 root of 11. So we need to do that.
You do not have to do that, as I said.
Oh, so why?
But because on the final exam you might have to. You might be asked 2 different things. That's the work from one of our first units. We're not going to ask you to simplify that right now, but you have to know how to do that. So let's practice.
So for a final exam,
Yep.
you like put this into radical form or something?
Might.
Oh, okay.